Welcome to SSR Pharma Media, your trusted source for pharma knowledge. Decode the pharmaceutics, MCQs made simple. So, under the pharmaceutics, we are going to discuss about size separation. Prepare, practice, succeed. So, under the size separations, we are going to cover classification of powders according to IP, sieves and standards of sieves, equipments for size separations, especially so cyclone separators very important in this equipment of size separation. So what is size separations? So size separation is also referred to as sieving, sifting, classifying or screening. The main law involved in size separation by sedimentations. So it's nothing but Stokes law. So sedimentation means it's indicating about Stokes law. So why? Stokes law explain the settling velocity of particles in a fluid, which forms the basis of sedimentation, alliteration, and centrifugal separations. So this is the Stokes law equations. So you read it. This is very important equations in the size separations. So move into the MCQs. Size separations in pharmaceutics is also commonly known as, so option C, sievings. So size separation is the process of separating particle based on differences in size. Which of the following terms is not associated with size separation? So option D is the answer, comminution. So comminution is the size reduction. So it's a size separations means it's mainly sieving, sifting, classifying or screening. Which of the following laws forms the basis of size separation by sedimentation in pharmaceutics? So option C, Stokes law. According to Stokes law, the rate of sedimentation of a spherical particles in a fluid is directly proportional to, option B is the answer, square of the radius of the particles. So square of the radius of the particles. So the explanations given under below the option answers, answer key, you read it, you will get more informations from the explanations. So next, classification of powders according to IP. So powders are classified as coarse powder, moderately coarse powder, moderately fine, fine powder, very fine powder. So this is sieve through the which all particle must passes and is a nominal aperture. Is a all particle 10%. So nominal aperture is 1.7 millimeter. Only 40% is passes. Sieve number 44. And nominal mesh aperture, it's a 355 micrometer and average aperture size 0.06. So if you study about the coarse powder means all particle must pass is 10%. 40% pass means the sieve number is 44. So all must pass sieve number 10. 40% means sieve number 44. So like that, coarse, moderately coarse 22 sieve number, same like that the aperture size, and it's 60 is the sieve number. So this is the micron size of the particles, and tolerance average aperture is 25, and moderately fine powder 44 sieve number, all particle must pass. This is the particle aperture size, and in the 40% of the particle passes sieve number 85 and nominal aperture 180 micron. And fine powder, so all fine powder passes 80% sieve number, 85 sieve number is the aperture, and there is no sieve number for fine powder. And very fine powder, all particle must pass 120 sieve number, particle size 125 micrometer. So a coarse powder must pass completely through which sieve number? So option B, sieve number 10. The nominal mesh aperture size of sieve number 22 is, so option B, 710 micrometer. Moderately fine powder must pass completely through which sieve? So option B, 44 sieve number. For moderately coarse powder, 40% of particle must pass through. So option B, sieve number 60. Fine powder corresponds to which nominal mesh aperture size? So option C, 180 micrometer. Which powder grade requires complete passage through sieve number 120? Option C, very fine powder. Arrange the following in decreasing order of particle size. So option A is the answer. Option A. So first is the coarse powder. So next is a moderately coarse and fine powder. Then very fine powder. So which pair is correctly matched? So option B is correctly matched. Moderately fine powder 180 micrometer, which passes 40%. So next, limit prescribed by pharmacopoeia. So pharmacopoeia has prescribed upper and lower limit for the 3 coarse grades of powder. For 2 fine grade of powder, the pharmacopoeia has prescribed only the upper limit. Grade type 3 coarse grade. So its limit prescribe both upper and lower. 2 fine grades only upper limit. So why only upper limit for fine grades? Means fine powders are difficult to control precisely. So hence pharmacopoeia prescribes only the maximum particle size 1. The area of clear opening of any 2 successive sieves according to Taylor's standard is the ratio of 1:2. So very important. There are so many questions they are asking. 1:√2. It is the Taylor standard. According to the Taylor standard sieve series, the area of clear opening of any 2 successive sieve is in the ratio of option B, 1:√2. For how many grades of powder does the pharmacopoeia prescribes both upper and lower limits? Option 3, 3. When a powder is described by a number, it indicates that option B, all particle passes through that sieve. For fine grade of powders, the pharmacopoeia prescribes option C, only upper limit. The nominal mesh aperture mentioned in fitness description is expressed in option C, micrometer. The lower limit in coarse grades of powder ensures option B, minimum percentage of finer particles. Minimum percentage of finer particles. So next is the size separation. The pharmacopoeial sieves are made of wire cloth which is square mesh woven from brass, bronze, stainless steel, other suitable material. So wires must have uniform circular cross section and should not be coated or plated. The sieve material must be chemically inert towards the substance being shifted. So number of sieves, number of mesh per 2.54 centimeter, 1 inch in each direction. So it's a nominal aperture, distance between adjacent wires, side length of square opening, nominal diameter of wire, thickness of wire forming the mesh. Determine strength and percentage sieve area. Approximate percentage sieving area 35 to 40% of total sieve area. So tolerance of average aperture, permissible variations in aperture size as per pharmacopoeial limit. So these are all the parameters and key points. So it's a high 2.54 centimeter and 25.4 millimeter. This defines define sieve number. Higher sieve number is used for smaller particles. Aperture size, distance between wire. Sieving area 35 to 40%. Tolerance, percentage variation allowed. Coarse sieve, smaller tolerance. Fine sieves, larger tolerance. The sieve number indicates the number of meshes present in option C 2.54 centimeter length. As sieve number increases, the aperture size option B decreases. Nominal size of aperture refers to option B distance between two adjacent wires. The nominal aperture size in IP is expressed in option C mm and micrometer. The approximate percentage sieving area is generally maintained at option C 35 to 40%. The main purpose of controlling the nominal diameter of the wire is to option C ensure suitable aperture and strength. Aperture tolerance average refers to option C allowable percentage variations in aperture size. The aperture tolerance average is smaller for option B coarse sieves. Which of the following materials is not suitable for sieve construction? So option D reactive iron. Wires used in pharmacopoeial sieves should be option C uniform circular cross section. The sieving area depends mainly on option B is the answer wire size used. So next is the parameters involved in the size separation. Force involved, mechanical sievers. So in that the sievers are mechanical sievers, cyclone separator, air separator, electrifications. So these are all the process of size separations and instruments are used in the size separations. And here the parameters force, mechanical vibration force and agitation force, centrifugal force are used under cyclone separator, and air drag force, centrifugal forces are used. So ellitration, gravitational settling. And mediums are no mediums required. Air is the medium. Air separator also air or liquid. Continuous process. So usually mechanical sievers are batch process. So yes, it is cyclone separators are continuous process. Air separator also continuous process. So ellitration is a batch wise. And best for coarse particle, it's a fine dust and fine classification, density based separations. Parameter particle diameter 5 to 10,000 micrometer, 2 to 50 micrometer, and gravitational 10 to 100 micrometer, centrifugal force 0.5 to 50 micron. Uses is a grinding for powder, granules, removal of oversized particles. So dust collections used for separating the heavy and or coarse fractions from fine dust. Separation of solids from gas and recovery of fine particles. Removal of fine from milled product attached to the ball or hammer mill for continuous classification. And its separation based on the size and density, purification of powders and particle size analysis. The force involved in a mechanical siever is option C is the mechanical vibrations or agitation. Which equipment works mainly on centrifugal force for separation? So option B cyclone separator. Which method is most suitable for separating coarse particles? So option C mechanical sievers. Filtration primarily works on Option B, gravitational settling. Which equipment requires air as a separating medium? Option B, both B and C. Both cyclone separator and filtration. C, cyclone separator and air separator. So here there is no option, only B is the correct answer. Here there is no option for air separations. Air separations. So only cyclone separator is the correct answer. Cyclone separator. If suppose they given the air separation, so in that case you have to use the both B and C. So cyclone separator here is the correct answer. Which of the following is a continuous process? Option B, cyclone separations. Air separators are commonly attached to option C, ball mill or hammer mill. Cyclone separators are best suited for separating option B, fine dust, nearly 2 to 50 micrometer. Filtration can be carried out using option C, air and liquid. Which method is most appropriate for density based separation? Option D, filtration. So next is the shaking method and mechanism of this screening of the particles. Shaking screen separated by oscillations and agitation. So mainly it is used for grinding of powders and granules. Rotex screen, oscillatory motions and vibration motions. Mainly it is used for large scale size separation in pharmaceutical and food industry. And bag filter is a type of suction or pressure principle applied. It is connected to the fluidized energy mill and pollution control. And scrubber, it's a impact and absorption is used as a principle, and it's mainly it's used for combined action of cyclone for separations of entire droplets of water. Shaking screen works on the principle of option B, oscillation and agitation. Rotex screen improves separation efficiency mainly by option C, oscillatory motions combined with vibrations. Bag filter operates on which principle? So option B, filtrations under suctions or pressure. Scrubbers remove particulate matter mainly by option C, inertial impact and absorption. Which equipment is most suitable for grinding powders and removing oversized particles? Option C, shaking screen. Large scale size separation in pharmaceuticals and food industry is commonly done using option B, vortex screen. Bag filters are mainly used for option B, collection of fine powder from air stream. Scrubber are mainly used for option B, removal of dust from gases. A coarse powder must pass completely through which sieve number? So answer in the comment box. Thank you. You'll join in our WhatsApp community. You'll get hands-on material and you check the playlist. You'll get all the videos. Thank you. Like, subscribe and share.